Bismillahirrahmanirrahim. Dear all the speakers of today's international seminar series, Professor Muhammad Hisham Lee, Bapak Ahmad Effendi, PhD, Dr. Rerpol Dedi Dwi Prasetyo, and Associate Professor Dr. Suhartono. Good afternoon. We are very honored to have you today. Dear all the academia at the Institute of Technology 10 November, at the Department of Statistics, especially the head of department, Ibu Dr. Kartika Fitriasari, all the committees, and the participants at the seminar. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah, all praises to Allah. Apart from any circumstances that we are facing today, we are all happy, healthy, and ready to participate in the international seminar series entitled Some Applications and Recent Developments in Application. This seminar is organized by the Department of Statistics, Institute of Technology 10 November, in collaboration with University Technology Malaysia, Brawijaya University, and Forum Pendidikan Tinggi Statistika Indonesia under the program of World-Class Professor. I am Ahmad Khairuddin, so today I will hold the role as the moderator of this session. The rundown of this seminar would be started by the opening speech by the presidents of Forstat, Forum Pendidikan Tinggi Statistik Indonesia, Associate Professor Dr. Suhartono, and then followed by photo sessions. And then afterwards, we're gonna have the main sessions of the seminar, which is the talk by our three speakers. The first talk will be delivered by Professor Dr. Muhammad Hisham Lee. And then afterwards, we're gonna have discussions. And the second talk will be delivered by Ahmed Effendi, PhD, followed by discussion session. And then the last session will be given by Dr. Rerpol Dwi Prasetyo, MSc, and continued by discussion session. And then afterward, there will be a closing. Bismillahirrahmanirrahim. Dear all the speakers of today's international seminar series, Professor Muhammad Hisham Lee, Ahmad Effendi, PhD, Dr. Rerpol Dwi Prasetyo, and Associate Professor Dr. Suhartono. Good afternoon, all our speakers. We are very honored to have you today. Dear all the academia at the Institute of Technology 10 November at the Department of Statistics, especially the head of our department, Ibu Dr. Kartika Fitriasari, all the committees, and all the participants at this seminar. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah, all praises to Allah. Apart from any circumstances that we are facing today, we are all happy, healthy, and ready to participate in the international seminar series entitled Some Applications and Recent Development in Classification. This seminar is organized by the Department of Statistics, Institute of Technology 10 November, in collaboration with University Technology Malaysia, Brawijaya University, and Forum Pendidikan Tinggi Statistika Indonesia under the program of World-Class Professor. All the participants, I'm Ahmad Khairuddin. Today I will hold the role as the moderator of this session. So the rundown of the session would be started by the opening speech by Associate Professor Dr. Suhartono as the President of Forum Pendidikan Tinggi Statistika Indonesia, followed by photo session. Afterwards, we go to the main session. The first talk by Professor Dr. Muhammad Hisham Lee, followed by the discussion session. And then in the second talk, we're gonna have Bapak Ahmad Effendi, PhD, followed by discussion. And then the last talk will be delivered by Bapak Dr. Rerpol Dwi Prasetyo, followed by discussions. And then at the end, we're gonna have a closing of the seminar today. So to start the session, I would like to welcome Bapak Associate Professor Suartono as a President of Forum Pendidikan Tinggi Statistika Indonesia to open the seminar. Please.
Okay, moderator, could you hear my voice?
Yes,
Hopefully
Pak
clearly.
Artono.
Oke, terima kasih Pak Ahmad Khairuddin. Ya, oke, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Ya, on behalf of Forstat, the Forum of Higher Education on Statistics in Indonesia, yeah, I want to say welcome to Professor Hisamli. I think the second time under world class professor scheme. Yeah, and all participants in this international seminar series under world class professor program. We have a very good topic about some application and recent development in classification. And the committee asked me to explain briefly about the overview of statistics study program in Indonesia, especially to Prof. Hisamli. First of all, I also want to welcome to Mas Ahmad Effendi, PhD from Brawijaya University. I think Mas Ahmad Effendi also met Prof. Hisamli 2 years ago when
Yes.
we have a world-class professor program at that time. Yeah, Prof. Hisamli came to Brawijaya University together with Professor Don McNeil. At that time, we held also the guest lecture at that time. Okay, I will explain briefly about the statistic in Indonesia before we open the session. Okay, I will check first. Okay. If we talk about the world-class professor, yeah, in Indonesia, for statistic lecturer, yeah, we have two world-class professor. The first is under Professor Dedi Rosadi from Gajah Mada University, and last month I think we have also the workshop series, and now yeah, we have the world-class professor under Dr. Repol Dedi Dwi Prastio, and mainly about the talk about the classification problem. And if we talk about the statistic in Indonesia, Prof. Hisam, yeah, we have statistics program, yeah, from bachelor until PhD. Yeah, now this, yeah, from Aceh, from Sumatra until Papua, yeah, already have about the statistics study program. And this is about some statistician in Indonesia from Aceh, from Unsia till the University of Cendrawasih in Papua. If we talk about the number of universities that held or run about the statistic in undergrad until PhD program, yeah, we can see from this slide, yeah, we have until now 37 universities run undergrad program. If we talk about the region, we have two region. Yes, sorry, we have. If we talk about this one, yeah, we have four region. Yeah, for Sumatra, we have four universities. In Java, we have 11 universities. Yeah, in Kalimantan, we have three universities. In part east of Indonesia, in Sulawesi, Maluku, and Papua, we have 8 universities. And if we talk about the bachelor in statistics in Indonesia, yeah, we can see, yeah, from the first region, second region, third region until fourth region, yeah, this the name of universities that already run bachelor in statistics. And if we talk about the master program in Indonesia, yeah, we have 6 universities already have master program. In West region, we have IPB University. I think last month or last 2 months, Prof. Hisam already visited uh, IPB University as keynote speaker in one seminar. And the second is Pajajaran University. And the last one is University of Bengkulu in Sumatra Island. And if we talk about the East region, yeah, the first one is ITS, Institut Teknologi 10 November. The second is Brawijaya University. And the last is the new one is Hasanuddin University in Sulawesi. If we talk about the PEC program in Indonesia in statistic, yeah, we now already have two universities PEC program. The first one is IPB University in Bogor, and the second one is ITS. And I think, yeah, Prof. Isam still remember this picture. Yeah, in this picture, yeah, this one is Prof. Isamli, this one is Prof. Don McNeil, and this one is our second uh, speaker now from Brawijaya University. Yeah, Mas Ahmad Effendi, PhD. Okay, and finally, yeah, congratulations to all participants. Yeah, in this international seminar series under World Class Professor Scheme held by Department of Statistics, Institut Teknologi 10 November, on the behalf of the Forstat, the Forum of Higher Education on Statistics in Indonesia, I open this activity. I give the time again to the moderator. Thank you very much.
Thank you very much, Pak Dr. Suhartono, for the opening speech. So, before we start the main sessions, I think that it would be and start the further session of this international seminar series, and then my colleague will take a picture of this session. Okay, thank you very much for all the participants and the speakers. Okay, so we come to the main sessions of this. The first speaker would be Professor Dr. Muhammad Hishamli, and I would like to read some of his curriculum vitae. So his full name is Muhammad Hishamli. He is a professor of statistics at the Department of Mathematical Sciences at the Faculty of Science, University Technology, Malaysia. Professor Hisham holds a degree in 1991 for the BSc, and then afterwards continued on the Master of Science in 1994 in the Statistics program of University Kebangsaan Malaysia, and hold a PhD degree on 2003 in Mathematics of University Technology, Malaysia. He is doing a lot of research based on the Scopus. He already made 119 documents, and then 1,207 citations with each index 19. So today, Professor Hisham will give a talk entitled High Dimensional Classification by Sparse Logistic Regression with Weighted L1 Norm Penalized Likelihood Method for Feature Selection. For all the participants, in the middle of the session, our colleague will provide the link to sign in of the seminar, so you could sign in. And then if you have any questions, you can type on the column of the chat in the Zoom or in the YouTube. Afterwards, we also have discussion session, and you can ask directly for Pak Hisham using the raise hand facilities in the Zoom. So without further ado, I would like to welcome Professor Hisham for the presentation.
Assalamualaikum. Can you see this one? The slide?
Yes, we could.
Yes. Waalaikumsalam.
Good. Alhamdulillah. Thank you very much, Dr. Ahmad Khairuddin, for your kind introductions. So I hope you can hear me clearly. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirrabbilalamin. Wassalatu wassalam ala rasulillah wa ala alihi wassabi ajma'in. Amma ba'. All praise to Allah subhanahu wa ta'ala. And very good afternoon to all my friends, ladies and gentlemen, and students of ITS and around Indonesia. I would like to wish everyone attending these seminars and their families and relatives good health, especially in the current pandemic atmosphere. We pray to Allah subhanahu wa ta'ala to lift the current pandemics, grant us victory upon our enemies' plot, and also slanders, fitna of Ad-Dajjal. Amin, Ya Rabbal Alamin. Thank you very much for attending today's sessions. So I can see there's more than 190 participants for today's sessions. First and foremost, I would like to congratulate Institute Teknologi 10 November, ITS, especially the Departments of Statistics, Faculty of Science and Data Analytics, and jointly organized Forum Pendidikan Tinggi Statistics, for stats, for successfully organized this international seminar series on some application and recent developments in classifications under the world-class professor scheme. I want to express my gratitude to Dr. Didi for inviting me to these WCP programs. It is a great pleasure to meet dear friends from ITS, especially Associate Professor Dr. Suhartono, the President of FOSTAT, and also Secretary of ITS. Congratulations on your recent promotion to Associate Professor. You definitely deserve it and more, inshallah. And also like to say welcome and have meet our Ibu Dr. Katika. Currently is the head of Department of Statistics. In previous meetings in IBP, I do notice Pak Wayu is there, so I do believe still can remember some familiar names like Pak Atok, Pak Harry, Pak Jerry, Pak Mashuri. I think probably I don't know whether still around ITS already go to Kalimantan, and our dear Dr. Muhammad Hassan, also Dr. Husna, a couple that come to UTMs before for sandwich programs. And I noticed Dr. Vinita also is here. She contacted me privately through the chat. Thank you. And many more, okay, in these virtual platforms. And also nice to meet you again, Dr. Ahmed Effendi. As Dr. Suhartono mentioned that we met in University Brawijaya back in 2018. It's a very nice experience. Okay, we take the trains. Okay, with Prof. Dons, have meals. So actually, I'm looking forward to come again in 2019. So after that, that doesn't happen. Then 2020, and this pandemics happened early this year. So inshallah, if we got opportunity, would really like to visit Indonesia again. Okay. I really have a nice food with Dr. Suhartono at that times. If not mistaken, today, as I mentioned, Indonesia holds a nationwide poll in elections leaders for provinces, regional seats, and also cities. So I think everybody have done their casting probably. So I wish you all the best for the outcomings of the elections. Okay. Inshallah, provide the best leaders. I sincerely hope all participants today, 100, now is 199, okay, can benefit from these seminars. Okay, today I will speak about one of the works I have done as recently with my colleagues and PhD students. So thank you very much for the nice poster. Right. So as the backgrounds, as I think most of us know, that the new application science advancements have made classifications with high dimensional features a strong interest. Okay, in recent scientific investigations and applications. Feature selection is one of the common known issues. It's past logistics regressions. As we can see that researchers introduce regularization techniques such as the least absolute shrinkage and selection operator, the Lasso, and we have like the SCAD and also like Additive Lasso to string the regression coefficient towards zero. High dimensional data refer to a situation where numbers of explanatory variables exceed the numbers of observations in a data set. As you can see in the slide that the applications for high dimensional data, or especially related to sparse logistic regression, can be found in many applications. Some of the example like chemometrics, econometrics, genomics, pattern recognition, and so forth. So these are some of the application that we can find related to high dimensionals. So the nature of the data normally is in high dimensionals. As for sparse logistic regressions, is considered as important in many scientific research areas currently. Basically, it explains the relationship between the response variables of interest and the numbers. Put this. Okay. Explain the relationship between the response variables of interest and the numbers of explanatory variables. Basically, we are dealing with situation whereby the design matrix have more columns than rows. Okay, and normally we'll be facing the multi-columnities issues. And also the matrix sometimes or most of the time will be in singulars. Okay. In terms of the challenges, we can see that the traditional estimation method such as OLS perform poorly. In terms of the Hessian matrix, normally is not full ranks, okay, and the iteration methods like neutral regression methods cannot work. So in terms of the issues, including like overfitting, estimation instability, predictions, interpretations, will be the challenges dealing with high-dimensional data. Variable selection, as mentioned, is one of the importance, okay, in high-dimensional data. So it play a vital role, okay, in sparse logistic regressions with high-dimensional data. Basically, the idea is to select a subset of important variables. In terms of research problems, Penalized method have drawn back, although it's introduced for high dimensionals. So the issue will be some on biasness and inconsistencies that make their lack of oracle properties. I also, in terms of encouraging grouping effects, have issue also in robustness. And for the estimations of the coefficients or S or MLE, neither correct in using the initial weight when there is highly correlated among the exponential variables or available, especially dealing in the situation where P is greater than N. And for estimation for the coefficient using lasso elastic net is a penalized method, also have some issue in terms of inconsistency variable selections. Okay, large coefficients can cause the L1 norms bias. Okay, because large coefficient will take more consideration penalties. Here are some of the research questions. So how to propose, okay, additive penalized method instead of the existing that I mentioned do have some challenges. What is the significance gains that achievable when we propose a new methods? What are the best criteria of performance for the proposed methods? And also how can the proposed additive penalized method be applied in real life or real situations? Research aims. So for this today talks, the research aims is to determine the sparse logistic regression modeling's accuracies, okay, on microarrays expressions, especially related to break cancels for high dimensional features. The research objectives are to improve the sparse logistic regression models variable selections with additive penalized techniques. Then we're going to compare the proposed method with popular penalized method such as Lasso, SCAD, Additive Lasso. To assess the proposed method classification performance with others penalized method dimensions, we're going to use the performance metrics, okay, such as classification accuracies, sensitivities, and also specificities. Penalized methods, okay. So for penalized method has shown to be useful in handling high dimensional method. So this is one of the innovations and approach when dealing with high dimensional data. Shrinkage is done by imposing the size constraints on the parameters. As you can see here, we'll be introducing a new terms, the penalized terms here. So the lambda j of beta here is the penalty terms, okay, which depends on the positive tuning parameter. So they have a tuning parameters of the lambda, So next is in this slide is solutions for performing variable selections and model estimations in high dimensional data simultaneously. So the good thing is penalized method able to perform this simultaneously in model estimations and also variable selections. The idea is to introduce penalty terms, okay, to the livelihood functions. By introducing these additional terms, you can control the complexity of the model and also to provide criteria for variable selections by introducing some constraints on the parameters. This constraint can force some of the parameter to be exactly zero, because the initial introduced method like Lasso, it cannot be exactly zeros. Okay, the amounts of penalty terms is a trade-off between the variance and the bias. So basically, we are dealing with these two, okay, to make the models or to select the models. Right. The amounts of penalty terms is a trade-off between these variance and bias estimations. So the idea here is that for small amount lead to more explanatory variables, okay, with little bias, but we going to face a high variance. So probably this is not what we desire. In the other hands, for large amounts of these penalties will lead to the few explanatory variables. This will give you a higher bias. Okay, if you have higher penalty, so you provide you a higher bias, but with less variance. So a good choice for the amount of penalty terms will improve the prediction accuracy. So this is the trade-off between these two. Next, I'm going to mention about the penalized method. One of is what we call as rich regressions, okay, introduced back in 1970s, basically to handle issue related to multicoloralities. So the idea is strings regression coefficients towards zero by adding L2 norms, a penalty, to the residual sum of square, but never equals zeros, right? Other method, it can be exact zeros. Hence, the variance of the parameter estimators are reduced, okay, which lead to better properties, both in estimation and also predictions. As a trade-off, the estimation parameters is biased, okay. Applicable in high-dimensional data, it does not have a capable to perform variable selections. So this is one of the advantage, but it's a good introduction, okay, in the early stage back in 1970s. So therefore, it does not give an easily interpretable models. Next is the Lasso method, introduced by Tipsharani back in 1996. Okay, he add what we call as L1 norm penalty to the livelihood functions. This can perform variable selection by assigning some explanatory variable coefficient to zero. The shortcomings of this penalized method is they cannot select more explanatory variables than the number of observations. Select one variable among the high correlated variables, and also lack of oracle properties. We have other methods like elastic net have been introduced. Okay, correlated based penalty also have been introduced, and also have the additive lasso penalties introduced by Zhao back in 2006. I also have other methods like additive elastic net, additive lasso penalties, okay, and so forth. In terms of the formulations for these penalized methods, as you can see for rich regressions, so they use the L2 norm penalties. Okay, so this is for the rich. So this formulation is summation of the beta square here. And for the lasso, so the penalty is L1 norms. Okay, so you can see they are using the absolute beta here summations. Additive here, you have using the weightage of them. Next is the lasso. Basically, cannot select more P than N. So lasso try to select one variable among the highly correlated variables. Okay, when there is no group of correlated variables. So also a lack of oracle properties. Let us start the penalized regression, logistic regressions by assuming Y be the Bernoulli random variables with parameters P. So we have a P parameters there. Let X1 until Xn be the independence random variables of X. So we have the N's there. And the response variables Y has Bernoulli distributions. So this is the things as you can see. And for the I is 1 until n. And then we can formulate the conditional probability of y is given by these formulas, okay, where j is from 1 until p. The likelihood functions for of the samples, okay, is this ones, okay, basically is this one, the product. Then we have the log, then we can have the log likelihood functions, okay, so it's given by these formulas, yeah. Next is this one, the penalized logistic regression model is defined by this, right? So we have this, then additional terms for the penalized lambda j beta. So lambda is the tuning parameters. So it starts from 0 or a positive value here. So j of beta is a penalty functions. And for the L1 penalizations of lasso is this j beta here is this one, is a summation or absolute value of beta j. Okay, so if this j beta here is equal to these formulations, then we have the penalized lasso, right? The maximum likelihood solution is given by this. So to get the beta head for the lasso, so it's through these formulations. Okay, so cannot select more than n variables. So cannot make group selections. Equally penalize all variable coefficients, making bias in variable selections, and so forth. And as for the additive lasso, it is by Zhao. So this is the formulations. Okay, so you have the tuning parameters there, and the beta is something like this. So you have this one. Okay, the beta hit here is the initial estimate for each beta j. Okay, using the lasso techniques. Different weight are used, okay, to penalize different coefficients in L1 norm penalties. So this is what we propose, okay, for this paper and for today's talks. So we're going to have a WJ, the weight inside the L1 norms as follow. So this is the weight. So we have the J there. So J is from 1 until P. Where J here is the weight for every predictors variables, okay? J that is defined as something like this. So you can see here, you have this one. Xj here is denote the column J across the row. And this sigma is the variance for the weight. Basically is have these two components, okay, for the first and the second, W1 and W2. So this denote the weighted variance, denote variance because you have the W1 and W2 for column J across columns. So belongings to class K equals to 2 because we are looking into the case whereby the K is equal to 2, meaning that we looking into the binaries case. In terms of the computational algorithms, okay, for this method, so this is the algorithms. So I put it as APLR, okay. So it's a additive, okay, penalized logistic regressions. So basically the algorithm is we're going to categorize each independent variables xj based on the value of y. So y here is binary. So we have two classes only. Find the mean and find the variance. Then we're going to compute the weighted variance here. And after that, we're going to compute the J, the penalized or the L1 here. Then we're going to find the WJ. Okay, then we define this one as WJXI. So then we can solve these equations here, okay, to get the beta height of this proposed method here. So the APLR equations have convex forms, so whereby to ensure a global maximum point can be achieved, then we can have efficient solutions. Okay, then the coordinate distance method can be used to solve the proposed method. So we have this data set, okay, to demonstrate the methods. So the data set is collected, okay, related to break cancers, where the data set have 569 patients with or without breast cancers, okay, have been quoted in this paper back in 2000 last year. I already update, but I don't know why it's come back to this figure. So basically here we have around 375. Okay, I already update. So but still okay, never mind. And we have 200 something here for the malignums. Okay. We have around the normal one, the benign cases. We have 357, okay, cases as considered as benign. Malignant, we have 200 something patients. So this data set basically obtained from these depositories, the UCL machine learning depositories, okay, is well known as WDBC. Okay, is Wilcoxon's. Okay, can be download this one medical data set here. This is collected by Dr. Williams. Okay, in terms of performance evaluations, we are using the classification accuracy, sensitivity, specificities. Okay, all the details is here. The formulations are quite standard. The idea here is that higher the value of the evaluation criteria, better the classification performance is. So meaning that if you have classification accuracy, you get a higher percentage, meaning that method is better than other methods. Okay, same to the rest. So the experiments randomly split a descriptor molecule into two partitions. So we're going to have the training set and also the testing set, okay, for cross-validation purposes for the test. So the split is 70-30%. The experiment using 10-fold cross-validations and average 100 partition times. So the tuning parameters is between this range, okay, depends on the training data set. The experiments for the SCAD here, the constant value A is 3.7. So this is mentioned by Fan and Lee because we use that one. This is the performance evaluations of penalized techniques, okay? So now we look at table 1 for the training data set. Okay, so for the training data set, as you can see here, this is the methods that we compare with. We have the lasso SCAD and also the additive lasso. And this is the features, the number variables selected. And this is the performance matrix. Here you can see here, this is a percentage for that one. Here is the standard error. Okay, so this is classification accuracy and so forth, sparsity. So from here we can see that the proposed method, additive penalized logistic regression method, provide a lower number of features, and the method also provide better accuracies in terms of classifications. As you can see, the percentage is higher compared to the rest. Okay. In table 2, so we performs for the testing data sets. Okay, so from here also you can see that the percentage is much higher compared to the rest. So what we can say is better accuracy in the classifications. We do this one comparison or t-test for classifications. So we are testing as you can see, all the p-values are smaller than 5%. So what we can conclude here is that there is a significant difference between the proposed method and other methods, okay, at 5% significance level, right? And also we continue to prove this one by comparing with other methods on the same data set, the breast cancer, Wilcoxon's diagnosis, the medical data set. Yeah, so it's the same. This has been compiled by Kadams, okay, by Kadams 2019. Okay, so this is the method that have been there, and this is the accuracy, the percentage. So many methods have been shown here. As you can see, this is all the methods. Okay, you have quite a number of methods here. So this is the authors. Then I will, because it's a long list, so I break it down. So here about 10 method here. So here another 10. So you can see the accuracy somewhere there. So this is another view. This is another view here, as you can see. And this is maybe the last slide. Okay. So you can see the proposed method here. So the accuracy is 98.90. So this is the things. So this is the conclusion that we can make. So in this study, this study aims to determine the sparse logistic regression modeling's accuracy on microarray gene expression high-dimensional features. So we improve the sparse logistic regressions model feature selections with a method, weighted L1 norms, additive penalized method based on high-dimensional data sets, microarrays gene expressions. And we compared it with several popular penalized methods, such as Lasso, SCAT, and also Additive Lasso. So the experiment results, okay, just now already show you some of the results here, shows the superiority of proposed methods over the other techniques, such as Lasso and so forth, especially in the numbers of selected descriptors and classification accuracies and sensitivity and specificities. More details can be found, okay, in this paper that have been published, okay, with my students and my ex-students, okay. This is a recent papers, and also some related publications of my works with my teams, okay, that Dr. Professor Zacharias, okay, Ayn, and also Yusrina, and also Dr. Adil. In high-dimensional data, so say some of the latest publications, okay, back 5 year publication, I just put 5 years. Okay, if you wish to have these articles, okay, you're always welcome to contact me. So I'm more than pleased to provide the article to you, okay. So with that, I would like to say thank you very much to ITS, FOSET, and also Departments of Statistics for inviting to these events, and also especially the WCP schemes, okay, for the second times. So it's indeed a pleasure to be with you all. And thank you very much. And thank you for your attentions. That's all. Thank you very much. Back to you, Dr.
Okay, thank you very
Ahmed.
much. Yes, thank you very much, Prof. Hisam, for the presentation. So now we would like to open for discussion session. So for the discussion session, all the participants are allowed to have any comments or remarks or questions, and you can either type it in the chat column using English or Bahasa Indonesia. It's gonna be okay as well, or you can ask directly to Prof. Hisam by using the raise hand. Okay, so we could start the discussion session now, and I would like to please you all for if you have any questions, remark, or comments. Okay, Prof. Hisam, actually there is one question in the, probably I would like to open it. So would you like me to open it on the screen or just hear directly from me?
Yeah, from you, I think it's fine.
Okay.
Oh,
So the question is about the meaning of the sparse here. What does that mean exactly?
Spatial meaning large, big, huge. Sparse, no? Sparse meaning
Yes.
big, huge. So it's we are talking about logistic regression only, meaning this is in a normal situation whereby the rows are more than the columns, whereby the n is the observation, the n is more than the variables or the parameters. Okay, this will be situations. So we use the normal estimation method like OLS, MLE, and so forth to estimate the parameters. We have no issue on that. So we have the techniques that's suitable for that ones to overcome or to get. Then we going to have a situation whereby an unbiased estimator can be found. And if you need for the MLE also, whatever method is suitable can be achieved through that means. But normally we use the word sparse because we are dealing with high dimensional data. So that will spark us to make difference from the normal logistic regressions. Hope answered.
Okay, thank you, Prof. Isam. There's a questions for Ibu Sarniber Liana, so I hope that it is answered the questions. If anybody, for the participants, if you have any questions, you can raise the hand and or type it in chat column. Probably I have one question, Prof. Isam, because actually on my PhD and also right now, I'm also working on penalized likelihood, but applied to the spatial statistics. And I also use some kind of method that you already presented, like Lasso, Additive Lasso, Elastic Net, SCAD, MCP, and etc. Regarding that, the one that you proposed, I guess that you proposed the new weighted for the adaptive lasso, right? Do you have any theoretical properties about that? Because you mentioned about the oracle properties that cannot be satisfied by lasso, for example, but satisfy the adaptive lasso by using some values of the weight. But now with the different weight that you propose here, do you think the oracle properties is still satisfied, or how it goes?
We're still studying in terms of the oracle properties. So by right, since we are using a non-lasso methods, by introducing the additive lasso methods as introduced by Zhao previously, only we make difference in terms of their weight. So by that, so we believe that the oracle properties basically have been addressed. Because the additive lasso basically addressing the oracle properties, but we have not shown it exactly to prove. But hypothetically, we believe so because lasso don't have that properties, whereby additive have that properties, but have not been doing so. So what we try to do is that rather than we go for that, so I'm asking my student and in our teams here to look at the problems first, look at how feasible is it. You are looking at the real data. Is it work very well? Then we'll start doing the simulation. After the simulations, then next we'll go for the properties if needed. Then very much depend on the strength that we have. Yep.
Okay. Thank you, Prof. Hisam. I think that we have more questions from the participants. Is it still about the oracle properties? So probably could you give that into more details about what is oracle properties, like what is it?
Oracle property, I think already mentioned. So it's just a definitions or the terms that we can use. It would be good just go to Google's and find what is the definition for that one. So I just give you here is mentioned what is the Oracle properties. Basically, is the probability of selecting the right set of explanatory variables. So when you select the set, basically is saying that it's a non-zero coefficients. So do have values for their coefficient. This converts into one, that is estimations of the non-zero coefficients. Basically here is mentioned as asymptotically normal. Okay, because you can gonna have the exact one with the same means and covariance. Okay, so this one must be same, the same means and covariance at if the zero coefficient were known in advance. Okay, if you Google, you will see some of the graph. Okay, to illustrate these the Oracle properties.
Thank you, Prof. Hisam. And
Well,
probably also Ibu Yulia asked me, you can also read the paper of Zhu, I guess, because it is the first paper of
yes.
the one that proposed the Oracle properties.
Mm.
Okay, Prof. Hisam, regarding the simulations experiments that you already conducted, so I wonder actually the one that you already compare with Lasso, for example, and the one that you propose, actually the one in the Lasso, it already performed well. I know that there is improvement that you made by the propositions, the proposed weight that you mentioned for this work. But I wonder why for the Lasso it also works quite well as well, like above 90% or something. Do you think it's not about like the simulation setting? Probably it's too, I don't know, it's too easy so that the Lasso can correctly have the good properties as well.
Yeah, it can be go either ways. The possible is, as you mentioned, can be many possibilities, but what is important is that if using Lasso by himself, I already mentioned here, they do have some disadvantage when we use Lasso. As mentioned here, the shortcomings here is always there. But probably we will get the same accuracy, but he will have some disadvantages in terms of group selections and so forth. They don't have this kind of properties. Okay, and also they cannot do it in simultaneously, as mentioned by me just now. Okay, in terms of the estimation and the selections. So you can get the same thing probably, but have a bit of disadvantage also. Yeah.
Okay.
It is a good start for people to do the comparisons, although you get almost similar accuracies.
All right. So thank you very much, Prof. Hisham Lee, for very nice discussions for this. If there are any other questions or remarks or comments. Okay, I guess that's all, Prof. Hisham, for the sessions with you, and we would like to thank you very much for joining us for this sessions, and we wish you a good health. And probably because we never met, Prof. Hisham, I heard a lot of you from Pak Hartono, from Pak Dedi, from Bu Kartika. It is the first time I met you virtually, and I hope that afterwards we can have more possibilities to meet and probably to have something together.
Nice to meet you. Thank you very much. Wabillahi taufiq. Wassalamualaikum warahmatullahi wabarakatuh. And stay safe. God bless everyone.
Waalaikumsalam warahmatullahi wabarakatuh. I think that we could have appreciation for Professor Hisham Lee. Okay, now we can continue for the next session. But before that, I realized that actually we have some troubles regarding the is my voice clear? or still there's some issue? Okay, great. So I think that we have some issue before the sessions of Professor Hisham Lee regarding the photo sessions. So now I think that it's time to the photo session. So I would like to invite all of the participants to open the camera so we could have the photo sessions before we go or we could continue on the next session. Okay, probably some of my colleagues, we can start the photo session.
Okay, does everyone has start the camera yet? I'm starting to take a picture. Whoa. Wait. Wait.
Is it okay, Pak Anton, or we could have more?
More time, please.
Okay.
Okay, this one. Page 2. Okay. Next page. Number 1. And for the last page. Okay, thank you.
Okay, thank you very much for all the participants. Okay, I guess that we can continue on the next session. So the second speaker, we have Ahmed Effendi, SSE, MSc, PhD. He is the head of undergraduate statistical program at the Department of Statistics, Faculty of Mathematics and Science, University of Brawijaya. He holds a PhD degree in 2004 from Statistics at the Institute of Technology, Sepuluh November. And then afterward, he continued the MSc and PhD in Belgium. He is doing a lot of research. Now he has 19 documents recorded by Scopus with 80 citations with H index 5. The title of the talk today of Ahmed Effendi will be about classification with some machine learning algorithm. So please, I would like to welcome Ahmed Effendi to start the session.
Terima kasih Pak Ahmad Hairudin. Suara saya kedengaran ya?
Sudah Pak, monggo.
Saya mau share screen saja. Belum dikasih akses saya untuk share screen.
Sudah, baru saja.
Ya, sebentar. Udah ya, kelihatannya?
Sudah Pak.
Baik, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Good afternoon, everybody. Thank you for the invitations. I would like to give appreciations to Statistika ITS Brawijaya, particularly Pak Hartono, ini dosen saya kayaknya, and other senior college di jurusan Statistika Universitas Brawijaya dan ITS kayaknya. Kemudian I would like to give appreciation also to Professor Hisham and Pak Dedi, the participants also of this session. Very glad to see you again, even though this is a seminar, online seminar. Maybe it will be the first year we hold this seminar online, and then the next year and so on it will be usual. Baik, Bapak Ibu sekalian, mix mungkin, tapi saya kasih slide dalam bahasa Inggris. Saya lihat partisipansnya semuanya di Indonesia. Actually, I also expected that the participants also coming from Malaysia. The college or friends from Professor Lee to also attend this. These sessions we have. I have give this talk about classification. Then about classification some machine learning algorithms. We are not quite used to this machine learning, even though this has been introduced in 60s. There was one book about machine learning in 1959 even, and then 1965, and until now, yeah, maybe the last decade. It is very popular. Maybe it is popular at the beginning, not in statistical field, but at the moment, I mean, within this decade, statisticians start to embrace this machine learning methodology. So in this presentations, I wrote, thankfully, up to this time, machines still require user input. If not, we will already depend only on machine. Nothing else more rather than machine. And then we do depend on machine. Like previously, like before these presentations, I have a problem of electricity here in Malang. Listriknya mati. So I was wondering whether I can continue this session or not. Alhamdulillah, at 12 something, almost 1 p.m. It's on again. So all participants, as illustrated here, that machine learning is not new thing, and some people argue that, or maybe ask about whether this is a particular method or not. I would start that machine learning is like several methods, but it's like a core of methodology, because it includes several methods even. And then this machine learning is part of artificial intelligence, AI, that has been introduced since decades ago. And then more specifically, this machine learning can be focused on deep learning. There is in intersections between AI, artificial intelligence, and machine learning, of course, and it's in deep learning. This is the origin of machine learning. I would not like to discuss in details further in this slide, but at least much of these informations based on this slide has the potential to inform this decision making if only there was a systematic way of making sense for it all. I have like diagrams. Yeah, no, not diagrams. It's like a nutshell of machine learning. Just to introduce to some people who are not still familiar, but I think I'm quite sure that majority of the participants here already know about machine learning. Just to remind that machine learning can be divided into supervised learning, unsupervised learning, reinforcement learning, etc. And then what we are statisticians are used to usually on supervised learning. We do regressions, we do prediction using regressions, we do classification, even image classifications, customer classification, diagnosis, all are part of supervised learning. Maybe also we are used to clustering, whether it's customer class clustering, segmentation, targeted marketing, etc. But all are part of machine learning. And then from here, we also know that this machine learning can be dimensional reduction also, dimensionality reductions, and not only factor analysis, for instance, or principal component analysis, but also robot navigations, learning tasks, skill acquisitions, all are part of machine learning. And then this is the algorithms I got from this website that machine learning, when we divide into supervised learning, unsupervised learning, reinforcement learning, ensemble learning, this is more diverse. Neural network and deep learning can be nearest neighbor, naive bias, logistic regressions. Maybe this one we are accustomed to it. And then polynomial regressions, linear regression, etc. Here, I would stress on this method because it's also familiar to us. And then the main reason of it, because I'm doing this methodologies. I'm doing this classification using these methodologies. And then using clustering, and then stacking, bagging. Maybe we are used to adaptive boosting. There is Adabus here. It seems it's new, but no, it's already introduced in 1990s by Friedman. And then more recently, it's HG Bush, even though it's not also new, about a decade ago. And then to do analysis, we use, me and my colleagues here in Brawijaya, in my team, use R or Python. This is not only because it is open source software, because it is quite powerful. quite powerful and it's very flexible and straightforward. There are some similarities and of course differences between these two software. But here I would like to use R because in this research I use R. Even though, of course, it's also it can also be done in Python. The study aims of these classifications on several machine learning methods is first to assess and compare the accuracy of several proposed methods. I use 8 classification methods, 5 classifications methods, and 3 ensemble-based classification method. And then the second aim is simulating the accuracy under several possible scenarios. Unfortunately, we don't finish yet the simulation under several possible scenarios using these all scenarios. I mean, but first we would like to give not introductions, overview that those 8 methodologies we try to implement to secondary data. We use primary data actually, but after we consult to a bank here, it's a BTN. Maybe orang Indonesia tahu kan ya, it's a BTN in Bali and Malang. Then we try not to use, even though in a paper we try to use it and we mention it Bank X, and then the management does not agree with that kan ya. And then we try to use data from a bank marketing data set from Portuguese banking institutions, that the data from 2008 May and until November 2010. There are several input variables starting from age, job, marital status, education, almost complete. And then the output variable to be measured is yes or no, whether the client has subscribed a term deposit. Kira-kira setuju tidak, kira-kira begitu ya, dengan deposit, kira-kira punya intensi deposit atau tidak kan. And it's not quite huge data, but it's big data kan, because we have 4,521 observations. Observation here mean people. So this Portuguese bank did like a survey kan ya, to ask several questions, etc. To 4,521 people. We try to split first the data into training and testing data with a proportion of 70% and 30%. Even though this is not exact, it is still possible to also introduce other proportions, for instance 65 and 35, but we can do it using simulations. And then doing it in R is very straightforward, and it takes only several minutes to finish. And then here I would like to mention also that in this data we have only 11%, almost 10%. The people that answer yes. So it's not balanced data, kan ya? That will be discussed later in the next presentation by Pak Dedi, kan ya? It is challenging actually because in several methodologies, like for instance Adabus, kan, even though is introduced in 90s, kan, it can tackle this unbalanced data. Kan. We later kan, ya, try to include this unbalanced data kan, ya, to our analysis. Kan, ya. This is the several methodologies, several methods we consider: naive bias, logistic regressions, K nearest neighbor, decision tree, chart, classification and regression tree, and then support vector machine or SVM. And also ensemble learning based methodologies. They are adaptive boosting, Adabus, random forest, SGBoost, extreme gradient boosting. We try to explore these all methodologies. First, naive bias. This is just for reminding to all of us. Bayesian classifier have been used for instance, text classification, such as junk email or spam filtering, author identification or topic categorization, and intrusion detection or anomaly detection in computer networks. The relationship between dependent events can be described using Bayesian theorem, Bayes theorem, that is based on this conditional probability that has been popular. And then I would stress on only maybe the weakness of this methodology. First, this naive bias relies on an often faulty assumption or equally important and independent feature. And secondly, it is not ideal for datasets with large numbers of numeric features. And its estimated probabilities are less reliable than the predicted classes. Even though this has some weaknesses, it has also strength of simple, fast, and very effective, etc. We do this using this package. It can be installed directly in R. Once you have the newest R, it doesn't need to be installed again. And then we use prediction also, and we come up with accuracy of 88% and kappa of 0.43. 88% is quite large, but in some predictions or classifications nowadays, 88% is not very large. So we try to use other methodology. That is classification based again, logistic regressions. Maybe we are used to it. Logistic regression is structure model approach. Is very similar to linear regressions. Only the response variable not continuous, binary or multinomial response variables. Like discriminant analysis, unlike K nearest neighbor and naive bias. Logistic regression is a structure model approach rather than a data-centric approach. We use this probability and we transform, maybe you already know, until we have logic, that is log of odds. And the odd is the probability, the probability of success and not success, the probability of A or not A, and then this is we use this R codes GLM, and then we summarize the model and we do prediction also, and then we come up with the accuracy of 89%, almost 90% here. We do again the classification using the K nearest neighbor. In a single sentence, nearest neighbor classifiers are defined by their characteristic of classifying unlabeled examples by assigning them the class of the most similar labeled examples. They have been used successfully for computer vision application, including optical character recognition and facial recognition in both still images and video. Here we use this also to classify whether or yes or no the clients of the Portuguese bank agree with deposit. There are some strengths and weaknesses of this K nearest neighbor. I focus on weaknesses. Maybe for accurations, some strengths people usually know, but people don't know still about the weaknesses. Some weaknesses of this K nearest neighbor are this method does not produce a model, which limits the ability to find novel insights in relationship among features. And it is slow classification phase. It's slowing classification phase. It requires a large amount of memory, even though the memory doesn't matter nowadays. Maybe this idea overcome. And nominal features and missing data require additional processing. Of course, the strengths, maybe you already know: fast training phase, make no assumptions, simple and effective. This is, I give small, brief illustrations about K nearest neighbor for clustering. This is if we have vegetables and fruits and proteins, directly plotting it, and then using K nearest neighbor, we can classify into vegetables, fruits, and proteins. They are different locally. So the vegetables, of course, they are combined together: green bean, celery, carrot, etc. And then proteins, there is shrimp, cheese, fish, nuts, etc. And then vegetables here, fruits, apple, grape, etc. So it's very straightforward using this K nearest neighbor, particularly in R. We are supposed to install only the library KKNN, K nearest neighbor. And then the result almost the same as the previous one, almost 90% with kappa of 28 something percent. And then we continue the same with the same classification method, now using decision tree. People already know about this chart, classification and regression tree, where we first come up with the whole data, and then we try to classify one by one. The data that is to be classified begin at the root node, where it is passed through the various decisions in the tree according to the values of its feature. The path that the data takes funnels each record into a leaf node, which assign it a predicted classes. This is very common methodology we use for credit scoring models, marketing studies, and in medicine field, we also use it for diagnosis of medical condition based on laboratory measurements, symptoms, etc. This is the illustrations of the decision tree. We have the data here, and then we try to split based on what variable first that is used to split. The first variable that is used for splitting is the most or high, very high, or it's not like significant. It has a high effect to the response. For instance, here we divide into low and high, and then here what variable that is splitting first, number of celebrities, and then the budget. So the number of celebrities here means that this variable affects more than budget variable in splitting. We try to use this analysis also, and then we implement in R using RPath. And there are several library actually for this chart, but use RPath. And we come up with the accuracy of, again, almost the same as the previous one, 90%. 90%. And the first to divide is post outcome, the outcome, and then marital status, and then job. It's a bit surprising that the job divides after marital status. Maybe in Portuguese society, that the marital status plays an important role, more important than the job. The next classification methodology is support vector machine. It's a family of binary classification algorithms, and then some applications of this support vector machine is classification of microarray gene expressions data in the field of bioinformatics. Bioinformatics already very massive, now in Europe, also in Asia, particularly for clinical trial applications. When I did master and PhD, it was in biostatistics. Some criteria, some examples, some work we already done there is about bioinformatics and biostatistics data, about gene expressions and about clinical trials. Even though when we come again to Indonesia is this data is a bit scarce. It's not very common in Indonesia to do clinical trials, even though there is a clinical trial in Jakarta, for instance, by Biopharma, AstraZeneca, but some clinical trials, they already know the methodologies of calculating, for instance, calculating how many patients, how many people that can be used for phase 2 trials, phase 3 trials. They already know. So in Indonesia or in some countries in Asia and Africa, they usually implement this methodology. They already calculate and give scenario of several simulations, and in this country, or some countries in Africa, they do implement directly give the trial to several patients in our country. So maybe that is the reasons we try to bit change the core of our research to some application in economy, including this one. Detection of rare yet important events like combustion engine in engineering is also quite used. And some weakness of this SVM is finding the best model requires testing of various combination of kernels and model parameters. It can be slow to train, particularly if the input dataset has a large number of features or examples. I think this one can be overcome with the computations nowadays. And it results in a complex black box model that is difficult, if not impossible, to interpret. This is some brief illustration. Linear case, non-linear case, with 2 dimensions, with 3 dimensions, etc. And we can also use this in R by, of course, download first this library, this package. And then we come up with almost quite the same, 90% accuracy. And then the next classification, okay. The next classification method we use is ensemble learning. This type of algorithm combines several models to achieve higher generations performance than ensembles. Ensemble methods are based on the idea that combining multiple weaker learners or stronger learner is created. Using this simple principle, a large variety of algorithms has been developed. So it's like combining, ensembling from the training data. We have allocation function using these algorithms, and we come up with combination function. Then there is a problem with the connection. Thank you.
Jelas, Pak.
Oke.
Mohon maaf Pak Ahmad, mungkin agak bisa dipercepat karena
Oke, dipercepat. Insya Allah. Directly, this is ensemble learning. Some criteria, and then we use ensemble learning also using adaptive boosting. Adaptive boosting already proposed in 1997, and then even though nowadays is still, of course, is still implemented and is still used by several researchers. And then using ADABUS, we come up with this classification accuracy and kappa. And then the second ensemble learning method is random forest. Random forest, I mentioned only here, due to their power, versatility, and ease of use, random forests are quickly becoming one of the most popular machine learning methods. This is the accuracy. It improves but a little bit. And then the last ensemble learning that is used here, we already implemented XGBoost. This is developed by Tian Kin Chen and Carlos Bustrin at Washington University. Directly coming, it's interesting actually to discuss about this XGBoost, because based on our analysis, it has huge improvement of classification precision. It come up with almost one accuracy. It's 99 something percent, almost 100%, and we try to compare all the methodologies, based classification based and ensemble based methodologies, and we come up with this accuracy comparisons of all algorithms. We try to leave to the audience because we are not sure yet whether this XGBoost is the most powerful, even though based on this data analysis, this is the best. This is it's not a conclusions, but just a short discussion of meme, where people using statistics doing the same things in 2009, a decade ago, and now they call it machine learning. We try to state that one does not simply run a regression and call it machine learning. Thank you very much for the audience.
Okay, thank you very much, Pak Ahmad Effendi, for the talk. So we would like to open for the discussion session. So I would like to welcome all the participants if you have any questions, comments, or remarks. You can either raise your hand or type it in the chat column. I would like also to remind you, if you have not yet signed in for the session, so you can sign in by the link that is provided by my colleague. And also for some of you who might miss the session from the beginning, you can also have later the recording in the YouTube that is also provided by my colleague afterwards. Pak Ahmad, actually, I have one questions. Actually, it is quite comprehensive study because you compare a lot of methods, especially in the machine learning methods. But actually, do you think that it's possible that one method perform best in any situations or something like that regarding the method that you already studied?
Yeah, that's true. Yeah. That's true, Pak Herudin. Here we try to combine not all, but several known classifications and ensemble-based methodologies to give overview to the audience that using this all methodologies has several advantages. These combinations actually we already know in meta-analysis. Even though it's not, it's different, of course, using analysis approach using this, and because the data also nowadays, for instance, if you use classifications data from Twitter, from WhatsApp, from maybe we have alumni in Bukalapak now, Mbak Putri kan ya. Now it's not in Bukalapak, it's not in Bukalapak, in Kementerian apa lupa saya kan. The data very it comes rapidly kan. So if we do classifications today, maybe next week it will be a bit different. So is the flexibility. We have used this flexibility to run the analysis. As a statistician, I think it gives me particularly not all of us, maybe only me, it gives me insight that we try to be very flexible in terms of methodologies and then give the results directly. Thank you.
Thank you very much, Pak Ahmad Effendi. There is one more question from Pak Hadi Suryono. So this is the question is actually about how to compare the methods, because the way how you present it is you choose the how you compare the method, it is using the accuracy. Do you think there is another way to compare the methods using other statistical testing? And regarding the accuracy, you also use the confusion method. Do you think it is enough, or should we use or consider another method to compare that?
In my mind, it has been enough. In my mind, it has been enough to use this confusion matrix. We try to use other like kappa values. You can also use, but still in line with confusion matrix.
Oke, terima kasih. Pak Ahmad, ini mungkin adalah pertanyaan terakhir dari Pak Ajiwasesa.
Yes.
Terkait dengan ADABUS dan XBUS, itu merupakan apakah adalah metode klasifikasi tunggal atau gabungan kombinasi dari metode klasifikasi?
Menarik ini kan ya. Jadi saya taruh di terakhir, slide terakhir kan ya. Jadi XBUS itu apa namanya? Kalau mau dibuat ini English, if we try to, tapi ini pertanyaannya bahasa Indonesia. Oke, nggak apa-apa.
It's up to you, Pak. You can either.
XBUS is a combinations also, but it's not like a meta-analysis. XBUS boosting. The criteria of boosting is also like comparing, not comparing, combining some criteria, right? So it's like adaptive boosting. So we boost using, and then we use adaptive boosting. And here, can use XGBoost is upgrade of adaptive boosting. Yeah. It's upgrade of adaptive boosting, and well, if simply you call it combination, it's not combination. Alright. Thank you.
Oke. Baik, terima kasih Pak Ahmad Effendi. Kalau kita lihat di chat ini, sepertinya akan ada banyak sekali pertanyaan karena ini memang topik yang
Yes,
sangat
we
menarik
invite
sekali.
the more discussions to our email or etc.
Yeah, I hope the discussions can be
later.
continued, ya Pak Ahmad Effendi, through
through,
email or something. So afterwards, after
collaborations or etc. Are welcome.
exactly. So I hope that after this session, we're gonna have more sessions on the discussions and possible collaboration.
That's true,
And
Pak.
I think that we could thank Pak Ahmad Effendi for the sessions today. And thank you very much, Pak Ahmad Effendi, for joining us for this international seminar series.
Terima kasih, Pak Herudin. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Baik, Bapak Ibu sekalian, mari kita lanjutkan untuk sesi berikutnya. So we're gonna continue the sessions. The third speaker we're gonna have Bapak Dr. Erpol Dedi Dwi Prasetyo, MSc. He is actually now head of postgraduate statistics Department of Statistics at the Faculty of Science and Data Analytics at Institute of Technology 10 November. So Pak Dedi holds a degree in BSc and MSc from Statistics of Institute of Technology 10 November, and then continued the PhD degree at Germany. He has 62 documents recorded by Scopus with 155 citations with each index 7. So today, Pak Dedi would like to talk about the classifications of imbalanced data using extreme value approach. So I would like to welcome Pak Dedi for the presentation.
Thank you, Pak Didin. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Nahmaduhu wa nusalli wa nusallimu ala rasulil karim. Rabbi shrahli sadri wa yassirli amri wahlul 'uqdatam min lisani yafqahu qawli. Firstly, I would like to say my deepest grateful to all the committee such that this seminar can be held successfully. And then I would like to say many thanks to the speakers, to Prof. Hisamli, who accept the invitation and to share his knowledge to all of us. And then to Mas Ahmad Effendi, who is my senior when I was in bachelor. I say grateful for your kind to accept my invitation to share your knowledge. Now I would like to present some of my research, particularly in classification, especially for imbalanced data, which is commonly found in the financial area, because the business process and also the regulation that impose that the data from the finance tend to be imbalanced, even extreme imbalance. Therefore, here I present one of the approach can be employed to analyze that imbalanced data, even the extreme imbalance data, using so-called extreme value approach. Okay, in the introduction, I just want to emphasize that the imbalanced data typically arise as a problem in classification where classes are not equally represented. So it means the proportion of one class is quite big, let's say 90%, 95%, and the other class is very small, 10% or 5% or even smaller. So this is the typical data in finance. For example, if we analyze the default data or non-performing loan data, so typically in the one class, which is the default class, is typically less than 5%. Why? Because the business process, the regulation on that business process regulate that it should be less than 5%. For example, in Indonesia, OJK, Otoritas Jasa Keuangan, it monitors the financial institution based on the Basel Accords, which is the international standard for banking and financial institution. It regulate that every financial institution must have internal credit rating system. It means every institution should build their internal system such that the non-performing loan can be very small. Maybe it is not possible to become zero, but it should be 10 to 0. And by regulation also, it is a rule to be such that a number, small number. Therefore, if we collect the data from that case, then of course the data will be imbalanced, extreme imbalance. The other example is in the churn data. Churn is, let's say, if we subscribe internet package, or we subscribe the TV cable package or others, then we resign to stop the contract. It is called churn. And then the others is default data. Default mean the someone or a company cannot pay their obligation. They cannot pay, let's say, monthly obligation. It can be a loan, something like that. So it is default. And fraud data typically happen in the credit card and many from finance. Then there is so-called accuracy paradox. Accuracy paradox means that the paradoxical finding that accuracy is not a good metric for here happen in the imbalance data. Let's say if we have two binary classes, one class is 5% and the other is 95%. If I say I just guess random, I predict all the observation will belong to one class. Let's say the one class is 95%. So it means if I guess randomly something like that without doing nothing, do nothing, then I will have accuracy 95%. So it's mean in this case, the simple model may have high level of accuracy, but it is too crude to be useful. This is the problem in imbalanced data. If it is balanced data, then it's okay. Accuracy is okay, but if it is imbalanced, if we just guess every observation belong to one class, so we will have accuracy as much as the proportion of the majority class, something like that. So there happen accuracy paradox. And then we need to have a strategies to dealing with imbalanced data. First, we can collect more data. If we collect more data, there is possibility that our data, let's say 2 class or more class, will be balanced for certain data, but for specific data it is not possible. For example, in finance, because the business process is, it force that the data to be or tend to be imbalanced. So we can collect more data, but in certain case it is not solution, because how many data we collect that's still imbalanced, like in a finance. Second, we can change the performance metrics. Say if accuracy is okay, it's good measure in balanced data, but it is misleading when we apply to measure performance of method for imbalanced data set. So we can use alternative, for example, AUC, area under the curve. The curve means the ROC curve. receiver operating curve. So it is commonly used in imbalance data, AUC. And the recent paper, let's say in the last 2 years, there are several paper have a simulation study. They show that AUC also has a drawbacks. So the paper proposed F1 score or F score. So this is the alternative. We can change or use another performance measure. The third alternative, we can do a resampling. Resampling means if the two classes is not balanced, then we can make copies from the, let's say, the smaller portion of class or underrepresented class. We make a copy of the data, so the data become doubling, it double or triple and so on and so forth, such that at the end the data will be balanced. Or the opposite, we can delay instant or observation from the majority class such that it decrease, and then at the end there will be balance data. It is called oversampling and undersampling. And then there is another approach, so-called example is synthetic minority oversampling technique, which is this is actually belong to oversampling, but it is not standard oversampling, but it is there is synthetic creation, creating synthetic sample from the minor class instead of creating the copies. So it means we generate with certain weights. There is weights, a formula there to make copies. I mean the synthetic copies from the minor class. Therefore, the minor class will increase. Therefore, at the end, they have balanced data. The third, I'm sorry, the number 1, 2, 3, 4, 5, the fifth, employ different algorithm. Let's say if it is not a success, we use logistic regression, we can use neural network, we can use naive bias, we can use random forest, we can use other ensemble method, we can use support vector machine and others. So it's mean we can try many others alternative. It's mean do not use our favorite algorithm. We study deep on certain algorithm and it become our favorite, and then we apply for every problem. So in particularly in the real case, we should make our algorithm or our methods is broader. We have to use more because no one method is superior that success or powerful to every cases. So we need to apply to other using different method or algorithm. Then the next we can employ penalize and regularized method, which is it was explained by Prof. Hisam in logistic regression, penalize, regularize, so-called lasso, list absolute shrinkage and selection operator, sketch, smooth clip, absolute deviance, and the combination of regularized term L1 and L2, it is called elastic net, and the combination of scat and L2 norm, it is called elastic scat and others. Yeah, Prof. Hisam also explained about the adaptive lasso. And there is others, there is called group lasso, there is many things. So it's mean why we need to do that, because let's say if we have many predictors, it is possible that the predictor has dependency. In statistics, we call it there is collinearity or multicollinearity. So if there is multicollinearity, it is there is dependency among the predictors. There will be problems, particularly for parametric approach. Let's say logistic regression, for example, or discriminant analysis. So the regularization or penalization, they impose penalty to the underlying model. Let's say in the objective function, which is likelihood or least square, impose with the penalty such that we can play if it is L1 norm like lasso and scat, it is it to feature selection or variable selection, because there is stationary point where is the first derivative in the point 0 is not available. Therefore, geometrically, it is can be mean that at that point it is non-differentiable. It means there is a feature selection in the first derivation. And then in the elastic net and elastic scat, because we add the L2 norm, which is L2 norm is not part of feature selection. This is used in ridge regression, which is employed to stabilize the parameter estimation. If we combine L1 and L2, then there will be so-called group selection. If several predictors are correlated, then we can choose the correlated predictor together, or we exclude the correlated predictor together. This is different from the lasso, which is select the strongest one. So we can do that also in imbalance theta. Sometimes several predictor is not relevant, where if we apply in the penalization, it means we solve some drawback, and yeah, it can perform better, something like that. So we can do that. The next one, we can try the different perspective. For example, if we have two classes and then we have minority and majority class, if we view that the minority is a rare event, if it is rare event, we detect as anomaly. So it is a different angle, point of view. We see the minority class as a rare event, and there is many more ideas. So my talk here is about in this. We see the minority class as a rare event. So in the rare event, we can apply this called extreme value approach. There are two approach in extreme value theory, so-called, say, first is block maxima, because it is from the data that the data it is time series data. If there is series and we make a block, the block is every 4 observation, and we choose the maximum point, maximum observation in each block, and we only pick the highest one. It is called block maxima approach. And the second one, we use peak over threshold. We determine certain threshold U. If the observation value greater than this threshold, then we assign that observation as extreme value. And at the end, we have less observation from the original, because we only select observation higher than the threshold. So there are two approaches. In the one approach of block maxima, there are 3 different distributions, so-called Frachet, Gumbel, and Weibull, to accommodate the skew pattern in the rare event or extreme event. If we combine these 3 distribution, Frachet, Gumbel, Weibull become one distribution. There is so-called generalized extreme value distribution. It is GEV. It is in the block maxima, and I do not discuss about the other one. It is the peak over threshold, because in the peak over threshold, it will converge to another distribution. It is so-called generalized Pareto distribution. But here in this research, I use the approach of block maxima and employ the GEV distribution function to apply it in classification. What is the idea? The idea is like this. Say we start from the simple one, as we learn about the Bernoulli distribution, and then we extend into binomial distribution, and we have logistic regression. Let's say if we have outcome or response is 0, 1, or success, failure. Say we only use binary for simplicity. If there is 2 binary outcome, the binary outcome of a certain random variable, it follows Bernoulli distribution. Then we have the PDF. Then we have the probability of success P, which is probability of response equal to 1. We assign that category 1 as a success and category 0 as the failure. Then if we impose a certain predictor, which the predictor X affects the affects the random variable Y, so it means there is response, there is predictors, then we can build the logistic regression from this formula. We have a probability of success given the known covariate or predictor. We have this formula, and the rest, the probability of failure is 1 minus probability of success, and we have the formula. And how the rare event or the extreme value come into play to the fields. Say, note that the P, which is there is no predictor, this is only single random variable followed Bernoulli or binomial distribution, or it is pi xi, it means there is predictors. So we play with model, let's say logistic regression model. So P and pi x is probability, right? We know that probability is between 1 and 0. Probability is between 1 and 0, okay? And then if from the different angle we see that minority class is seen as a rare event, then extreme value theorem can employ for classification by employing the CDF, the distribution function or GEV, F instead of pi, because F is between 0 and 1, because this is CDF, and pi is between 0 and 1, because it is also probability. So if we have CDF, FZ, this is the CDF from GEV distribution, where is tau is shape parameter, mu is location parameter, and sigma is a scale parameter, then we can develop the link function which relate the predictor and the response. So if the response is affected by the predictor, and we can have the probability of success y equal to 1 given by known predictor, so we call pi xi. It is the CDF from the GEV distribution, and we have this link function. This model is called generalized extreme value regression. So from the extreme value distribution, we can build the link function, and we develop a model for classification, so-called GEVR, generalized extreme value regression. Okay, the current work, we apply this generalized extreme value regression in financial distress prediction. Some development we also, or my team, I and my team already built or developed so-called multi-period GEVR for time to event data. It is for survival data, because for survival data, every time point we can see that every time point the observation is survive or not, survive or not, survive or not. So if we say survive yes or not, yes or not, so it means in every point we have classification. And if we have time to event, this is survival time, then we can employ so-called multi-period modeling. You can see some of my paper. We have already some paper about multi-period logistics, something like that, and we extend to multi-period GEVR. So it is done, but it is not presented in this talk. I do not provide in this talk, but I just mentioned that we have done that. And GEVR selected with feature selection, we can apply with, let's say, backward elimination, forward elimination stepwise. Of course, we can also apply or extend using regularization, but it is, of course, still something I want to do. Not, it is not done yet, but I want to. It is still ongoing. And then we also apply to the where the predictor there is so-called synthetic feature generation. So we can use a combination of addition, multiplication, and others operators to have new features. So actually we can have a large feature because the operation of addition or multiplication and so on and so forth. We can apply the method to that. Then we have a very high dimension data. Okay, this data applied to the financial distress. The financial distress assigned with y equal to 1. It is assigned to a company when the interest coverage ratio less than 1. What is interest coverage ratio? If a company, they have a loan, they have debt, they need to pay interest. So it's mean if every month the the return they receive, the amount is equal to the interest they need to pay, then the ECR will be equal to 1. It means if ECR less than 1, it means the income or the return of a company, it is not enough to pay the interest only. Because there is additional operation cost, something like that. So it means the company in trouble situation in terms of the financial. It is in financial distress, or the return on asset, whatever the asset, it is big or small or large, the return on asset less than 0. It means the return on asset is negative. So it means there is no profit. The company does not produce profit. So if there is these two combination, this either these two possibility, ICR less than 1 or ROA less than 0, then we can assign y equal to 1. And of course, we can also do if ICR less than 1 and we use n. So actually, this is also has been done, but I do not present in this talk. I only present when we apply to the first condition, the ICR less than 1 or the ROA less than 0. We employ 14 financial ratio as microeconomy predictors and the 4 macroeconomy indicators. Why we do this? Because let's say in the model setup, we assume that observation is independent, like in logistic regression, support vector machine, we assume that observation is independent. But if it is in economic data, we calculate from 2005 quarter 4 until 2018 quarter 4, it is actually annual data, actually panel data. Actually, there is dependency, but if we accommodate that dependency in the model become quite complex. First, we assume that observation is independent. If there is one company going default, it is typically affect the market. One company bankrupt, and then it's affect the market, and the market affect other companies. So it means we try to capture the indirect effect when a company going bankrupt, the effect to other companies. So we incorporate the microeconomy indicators as the predictor. And then we apply this to industry sector. So because we analyze in the certain sector, because different sector have different business process, therefore the financial ratio have different meaning. In total, we have 2030 observation, and there is some missing value there. We make imputation using KNN approach, and we split the data become 80 and 20%, 80 for training and 20 for testing. There is also drift concept. Drift concept mean, let's say the response Y in current year is affected by the predictor in current year. So it means response and predictor calculated from the same year. It is the drift concept with size 0. If the drift concept with size 1, it means the predictor in the last year, in the one period previous one time lag, it affect the response in current year. So it means there is a time lag in the predictor that affect the response. So actually we also try this also until size equal to 3. It is already done, but we do not present here. We only provide when size equal to 0 in this presentation. This is actually how the illustration, the drift concept, how to construct the predictor and response, and training and testing with size equal to 0 until size equal to 3, and we present only in size equal to 0. And we apply backward elimination in the feature selection for GVR when we also apply the benchmark model, which is support vector machine, and then Lasso support vector machine. So it's mean we apply penalization in the SVM. So let's say in the L here, L is loss function. Loss function, if it is logistic regression, it is log function. Log loss function. If it is in SVM, it is called hinge loss. And another method have other loss function. So in SVM we use hinge loss, and in the logistic we use so-called log loss function. So we apply to Lasso SVM, elasticness SVM, logistic regression, Lasso logistic, and elasticnet. So Lasso is L1 norm here, the formula of the L1 norm of the parameter beta, the vector, vector parameter beta. If we combine with the L2 norm, it is called elastic net. And of course, this some tuning parameter or the weights we can modify this. It affect the derivation. It doesn't matter. It always can be modified. And then we need to tune the parameter lambda. And then if we set the gamma equal to 1, it means the elastic net become lasso. If gamma equal to 1, then the L1, the L2 norm disappear and it become only L1 in the model, and it is called lasso. Then we also make exploratory data analysis about the characteristic of the data in addition to the descriptive statistic. So if we only provide a mean, median, modus, a variance, standard deviation, coefficient of variation, something like that, it is only a single point or single point statistic, which is we cannot get the more view. So here we provide the kernel density estimator to EBITDA, earning before interest and tax. This is the financial ratio, one of the financial ratio. We display the kernel density estimator to know the distribution of EBITDA, the predictor EBITDA for each class. Class financial distress equal to 1, which is the distress company, and then the financial distress equal to 0, which is a financially held company. So we can see that the predictor EBITDA is a significant affect the financial distress. It means this EBITDA have different characteristic for class of distress company and the class of non-distress company. And we do the same way for the rest of the predictor. And the end, we compare the performance. Say, firstly, we use the AUC and accuracy for a model without feature selection. So we compare SVM, GEVR, and Logit in training and testing in using accuracy and AUC, area under the curve. We can see that the GEVR, the extreme value modeling approach, outperform the benchmark model in training, in both training and testing. And then the next, if we employ feature selection, Lasso, elastic net, we penalize to the Logit and SVM, and then in the GVR we apply backward elimination. We do not apply Logit, Lasso, elastic net, SCAD, and so on and so forth, because we do not develop yet. But we are developing it. We want to. Hopefully, we have many energy and many time to finish that dreams. Okay, if we apply feature selection, we can see that the AUC accuracy for GEVR with backward elimination still outperform the benchmark. So it's mean we
I'm
can
sorry, Pak
conclude that
Dedi.
here.
Okay, so this is the conclusion.
Yeah, this is the last slide. Sorry, the GVR with and without feature selection outperform the benchmark. From we already mentioned the benchmark, and from the variable we use, we have some financial ratio. This is from microeconomic variable, and the macro, which is Bank Indonesia 7 days repository rate. This is significant within the GEVR model. This is the conclusion of my talk. Thank you very much. Hopefully, it's give more knowledge for all of us. Thank you. Time back to Pak Didin. Thank you.
Okay, thank you very much, Pak Dedi, for the presentations. So we would like to open for the discussion session. So it seems that we already have some questions, Pak Dedi, so I would like to go directly to the discussions. So the first question is from Bu Wiwi Anggreni. What things should we notice when we want to generate new synthetic data? Is distribution is one of them, or we could do something else?
Yeah. Okay. So one example to generate a synthetic of the data is Smothe. Smothe, they use weights. Let's say if we have one observation, the first observation, second observation, and then we can calculate the distance between the two observation, and then we can put the weights combination. We can put the weights combination to generate the new data. So this is how the Smothe work. But of course, we can do the other way. This is the research, particularly if the research is data driven. So we do not have theory that's imposed in certain direction, but we can do many point of view. So this is one way. One way is we give weights of observation to generate the synthetic. If we want to put the weights, it is based on distribution. It is also possible. It is also possible. I mean, there is existing method, which is one of the Smothe, but there is other possibility to develop other methods. Okay, this is the first question. Hopefully, satisfy the.
Okay, thank you very much, Pak Dedi. So the next questions that I directly go into the screen that I share.
Yeah.
This is about
Yeah.
The method or the approach that could be used when we want to cite
Yeah.
or use time series data. It is also one of my
Okay.
questions. If
Okay.
you have a correlated data, I know that
Yeah.
it is not
Okay.
included in your research, but probably
Okay.
you have any idea.
Yes. Okay. Actually, many my papers also about applying machine learning for time series data. Particularly my research and with Pak Hartono research. Say in the time series data, because it is time sequence data. If let's say we split testing and training, of course we need to split based on the sequence of the data. We cannot split randomly, right? Therefore, if we apply something like ensemble, this is resampling. Ensemble is just another word of resampling, something like that. We cannot do random resampling. The resampling should be based on pattern. Let's say, if it is time series, in certain period, there is a pattern. Let's say the pattern is trend or the pattern is seasonal. So we need to cover this pattern in our resampling time series. One of the method is so-called sieve resampling. This is how do resampling in time series. So it means the resampling in time series are not allowed to change the pattern. This is we need to consider. The resampling should still keep the pattern same as the original. Okay, this is the first thing. The second one, in the time series, you can see a lot in Pak Hartono in my paper. We also did many simulation. In, let's say, if we have a single series, it means we only have one random variable. So we do not have response and predictor, right? So we can use the idea of ARIMA. ARIMA is, let's say, a series affected by the time lag of that on series. So it is the series is affected by the itself, but in the time lag. So it means we can employ the time lag of a series as the predictor, and we apply in the machine learning. And you can find in our papers, some of them with Pak Nofri also, that one we apply machine learning in time series, one of the main step or the key step is choose appropriate input. It means if it is single series, it means we have many possibility of time lag. It means we need to choose appropriate time lag as the input. If it is seasonal, we need to select the time lag cover the seasonal pattern or something like that. So if it does not like that, then the performance not typically not really good. You can see the participant can see in some of our paper we already simulate with some scenario. One of the key step or key point in selecting feature in time series using machine learning is select the appropriate time lag. We can use say scatter plot from lag 1, lag 2 until many lag. But the problem is, let's say if we have data every half an hour and we have several years data, so we will have multi-seasonal pattern. The seasonal in daily seasonal, weekly seasonal, and calendar variation typically if it is Indonesia. So we have 3 seasonal pattern. So it means the time lag is quite big. Let's say it's become 300 something time lag or 1000 something time lag. Sometimes the package in our it doesn't work. It doesn't work. Let's say if we only put maybe only something 200 something. More than that it doesn't work. So be careful on that. Okay. I think this is my answer, Pak Didin.
Okay, thank you, Pak Dedi. I think that we are open for one more questions or comments or remark if you have any. Ibu Devi Yusti, we see that Ibu Devi raised the hand, so you can unmute it yourself and ask directly to Pak Dedi, please. Ibu Devi Yusti, if you have any questions, comments, or remarks, you are welcome to directly pose to Pak Dedi. Okay, so we are waiting for Ibu Devi, but I have one more question, Pak Dedi, regarding that the distribution that you chose. Actually, we have more parameter, right? You said about location parameter and scaling parameter. I wonder how you estimate those parameters. Are you using like the maximum likelihood, and then afterwards you use kind of Newton algorithm, quasi Newton, etc., something like that, or you have something particular?
Yes, it's correct. It is we employ the maximum likelihood, but the solution is not closed form.
Exactly.
Then we continue with the numerical iteration. Yeah, and we see if we use more numerical iteration, then there is some we need to consider. For example, if it is the derivative based method, let's say Newton-Raphson, it is sensitive to the initial point, right? If we have many possibility of combination initial point, then it is possible we trap in the local minimum or maximum, something like that. So we can also employ the free derivative algorithm, such like genetic algorithm, particle swarm algorithm, simulated annealing, and other evolutionary or environmentally inspired algorithm, which is typically free derivative. So this is one of possibility to do that.
Okay. Do you have any idea, Pak Dedi, how does that converge?
Yeah, based on the empirical, because if we apply using let's say derivative based iteration, yeah, sometimes fail for certain initial point, because we do not know in which initial point which is close to the maximum global one. Yeah.
Okay, thank you, Pak Dedi. So I think that we could thank Pak Dedi for very nice sessions, discussions, and we could continue the discussion session, I guess, outside of the session, yeah, Pak Dedi. So thank you very much, Pak Dedi and all the speakers. So I think that this is the end of our sessions in the international seminar session. I would like to thank all the speakers, Professor Muhammad Hisamli, Pak Ahmed Effendi, PhD, and also Dr. Dedi Dwi Prasetyo, all the committees, and also all the participants. If you want to sign in the seminar, the link is already provided by my colleague in the column chat. This recording will be also uploaded in the YouTube. So if you miss some part of this session, you can go back to our YouTube channel so you can look into more details on that. So I would like to thank you for all the participants, and I would like to apologize for any mistakes and troubles. We wish to welcome you again on the next seminars. And thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam
Waalaikumsalam.
warahmatullahi wabarakatuh.
Thank you everybody.
Assalamualaikum warahmatullahi
Pak Ahmad dan everybody.
Terima
Thank
kasih, Dedi.
you.
Pak Ahmad.
Oke, semua Bu Kartika.
Alhamdulillah.
Waalaikumsalam.
Reuni di sini.
Monggo Pak Didin di end host.
Oke.
Hostnya Pak Dedi.
Oke, saya N ya.